All right, so next up is the relationship between the errors, okay? So type 1 and type 2 errors will have an indirect relationship. So as the probability of one increases, the probability of the other decreases, okay? So we know our type 1 error is set with our significance level, which is our alpha. And then here's where things like might be a little odd or might be a little confusing. Say, okay, because the higher our significance level is, the higher our alpha is, the lower our probability of failing to reject becomes, okay? Which is why alpha and beta have an indirect relationship. So as like a little like visual example, so again, as our alpha increases, so as our significance level increases from here, we have 1% here to 10%, we're capturing more p-values, which means we are more likely to reject, okay? Which means our probability of failing to reject gets lower. So the more likely we are to reject, the less likely we are to fail to reject, okay? So there, hopefully that makes some sort of sense, okay? And then the higher our significance level is, the more likely we will, again, so reject the null, okay? Which is again, same situation. As our alpha increases, we are more likely to reject the null, okay? And then this will increase the likelihood that we do that incorrectly, okay? So, and it also increases the likelihood that we also do it correctly, okay? So that means as we increase our significance level, we're more likely to reject the null, which means we're more likely to do that incorrectly if we make a mistake with like a false positive kind of thing, or we do it correctly, okay, where we should have rejected it. Okay, so I know that sort of seems a little counterintuitive, but just as we increase, we have more false positives, and we also make the correct decision more often. Okay. All right. And then therefore type 1 error and power have a direct relationship. Okay, so now let's look at interpreting some errors. Okay, so some examples. So what type of error would you rather have? Well, that depends on the problem. We talked about that. For some tests, we want a low type 1, but for others, we want a low type 2. And this is why being able to interpret errors is a key skill for the AP test. Okay, so let's see an example. So it's a drug manufacturer that claims that less than 10% of patients who take its new drug for treating gestational diabetes will experience nausea. So to test this claim, researchers conducted an experiment at the 5% significance level. So what are the null and alternative hypotheses? Well, let's see. Our HO is going to be that exact claim. So 10%. Okay. All right. And the claim that with their new drug, it's going to be less than 10% of that. Okay. All right, so it says to describe a type 1 and type 2 error in this setting and explain the consequences of each. Okay, so I find it helpful on these type questions to always sort of draw a little, let me give me a little bit more room, to draw sort of a quick box. Okay, just like we did on the front page. Here we have the truth. So this is the truth. And then on this side, we'll have our decision, okay, which is going to be a little bit backwards. So we have HA here and HO there, okay? So in the top left box, this is type 1 error, where we reject when we should not have rejected. We have power here, where we correctly reject. We have a correct decision here, where we fail to reject when we should have failed. And then we have type 2 here, where we fail to reject when we should have rejected, okay? So again, using this situation. Okay, so describing a type 1 error means we say less than 10%. So type 1 error is up here in the top left corner, means we are rejecting, we are failing to reject when we should have rejected, which means we say that the alternative is true when it's really the null. So we're saying that less than 10% of patients experience nausea. I'm sorry for changing the color, but I'm already moving. So patients experience nausea. How do I spell that? Experience nausea. That's close enough, whatever. Nausea. okay? But when really they don't, okay? So if we say that less than 10% of the patients experience when they don't, that means we're not going to do anything when we should, okay? So that means the manufacturer won't do anything when they should, okay? And then type 2 error, okay, this is where we fail to reject when we should have rejected. Okay, so we're saying that we say that 10% of patients experience nausea when really it's less than 10%. Okay, so what does this mean? Well, if 10% of patients are, if we say that 10% are experiencing nausea when it's really less than 10%, that means we're going to spend time and money to fix a problem that isn't there, okay? Because we're trying to get it to be less than 10%. And if we say that they are 10% and the drug is actually making it less than 10%, we shouldn't be doing anything because it's working, okay? So this means the manufacturer will spend time and money fixing a problem that isn't there. Okay. All right, let's see. This test has a power of 0.54 to detect if the alternative is true. So explain what the power means in this setting and what is one way we can increase the power. Okay, so the power means that we reject when we should have rejected. Okay, so that means the probability that we find less than 10% experience nausea correctly is 54%, 0.54, okay? So one way that we can increase the power, remember we talked about that up here, when we increase the power, where is it at? So type 1 error and and power have a direct relationship. So as one increases, the other increases. So that means if we want to increase the type 1 error, then we increase our alpha. We increase our significance level. So increase significance level. Okay. And then last up it says, you know that the power of this test is at 5% significance level against the alternative is 0.54. If you decide to use an alpha of 0.1, which means we're lowering the significance level instead of the 5% with no other changes to the test, will the power increase or decrease? Okay. So if we're decreasing our significance level, that means power will also decrease. Okay, and this is because the probability that we reject the null decreases. All right, so again, this is just a bunch of like trying to memorize this, and it just takes a lot of practice.